In the next operating room revolution, the most terrifying moment may be the second when the surgeon lets go. Because for the first time in medical history, engineers are building robots that do not just hold tools, but can begin to understand procedures. Not science fiction, not a fantasy prototype, but real autonomous surgical systems already tested on living tissue in research labs. And what happens next could change not just surgery, but trust itself. Because once a machine can cut, clamp, suture, and correct its own mistakes, the question is no longer whether robots belong in the operating room. The question becomes who is really in control when a human life is open on the table. Surgery has always depended on one fragile thing: human performance under pressure. Even the best surgeon can shake, hesitate, misjudge distance, or simply get tired after hours of microscopic decisions. And inside the body, millimeters are the difference between recovery and catastrophe. That is why robotic surgery became so attractive in the first place. Machine scale Schulter tremor perfectly steady, and reach anatomy that human wrists were never designed to touch. But for all the futuristic marketing, most surgical robots today are still master-slave systems, meaning the robot moves only because a surgeon tells it to move. In other words, the robot is powerful, but the intelligence is still mostly human. Autonomous surgical robotics tries to break that limit. But autonomy in surgery is not one giant leap from human to machine. IT is a ladder. At the bottom, robots assist with motion and guidance. Higher up, they can automate subtasks like planning a cut, aligning an instrument, or following anatomy under constraints. At the top, true autonomy means the system perceives tissue, chooses actions, adapts to change, and executes without continuous manual control. That highest level is the part that still feels almost impossible. A 2020 systematic review of FDA-cleared surgical robots found that most were only level 1. A few reached conditional autonomy, and none were fully autonomous. So the future is not already here. But it is much closer than most people realize. The first major shock came from a system called STAR, short for Smart Tissue Autonomous Robot. In 2022, STAR performed autonomous laparoscope intestinal surgery on a pig with supervised execution and remarkable precision. That mattered because soft tissue is messy, slippery, deformable, and far less predictable than bone. Bone is architecture. Soft tissue is weather. Then came the next leap. In 2025, Johns Hopkins researchers unveiled SRT-H, a hierarchical autonomous surgery framework that could adapt in real time during a gallbladder procedure step on pig tissue. Unlike earlier systems, it was trained from surgical videos and language annotations, so it learned not just motions, but the logic behind a sequence. The researchers described it as a move from teaching a robot one fixed rote to teaching it how to handle the road itself. That difference is everything, because surgery is not a scripted performance. It is controlled improvisation inside a living body. To understand autonomous surgical robots, imagine 3 layers working at once. First, perception. The machine has to see boundaries, tool position, bleeding, risk motion from breathing, and subtle changes in color or tension. Second, planning. The robot must decide what step comes next, which tool to use, where to move, and what to avoid. Third, control. The system must translate that plan into smooth, safe motion without tearing, slipping, or drifting off course. And then there is the hardest layer of all, recovery. Because real surgery goes wrong in tiny ways before it goes wrong in big ways. A capable autonomous robot must notice those tiny failures early and correct them before a human even needs to intervene. That is why recent systems are increasingly trained on video, sensor data, and feedback loops rather than simple hard-coded rules. The robot is not memorizing one surgery. It is trying to learn what matters when surgery stops behaving normally. The promise is not just cooler technology. It is consistency. A robot does not get sleepy on the 4th hour, distracted by noise, or overconfident after 100 successful cases. In theory, autonomy could reduce variability between hospitals, surgeons, and even countries. It could also make expert-level technique more scalable in places where elite surgeons are scarce. And industry sees something even bigger. Today's robotic surgery market is already enormous, led by surgeon-controlled platforms performing millions of procedures every year. Intuitive said more than 3.1 million Da Vinci procedures were performed in 2025 alone, and the company marked 20 million patients treated by the end of that year. That scale matters because autonomy will not arrive in a vacuum. It will emerge on top of an operating room ecosystem that already exists. Cameras, force sensing, analytics, cloud review, simulation, and AI guidance are the stepping stones before full autonomy ever reaches patients. But this story gets dangerous the moment hype starts outrunning biology. Human bodies are not standardized machine parts. Anatomy varies, tissue quality varies, inflammation changes landmarks, and one unexpected bleed can collapse a neat plan in seconds. That is one reason the most dramatic autonomous successes so far remain preclinical and tightly studied rather than routine human operations. Another problem is accountability. If an autonomous robot makes a bad decision, who owns that error? The surgeon, the hospital, the manufacturer, the software team, or the data that trained it? Then comes trust. A patient may accept a robot guided by a surgeon. Accepting a robot that makes decisions on its own is a much deeper psychological leap. And because these systems depend on software, data, and connectivity, cybersecurity and transparency become patient safety issues, not just IT issues. Even the best autonomous system will need validation frameworks, long-term monitoring, and careful real-world study before society can trust it at scale. So no, tomorrow's hospitals will not be run by unsupervised robot surgeons. The more believable future is layered autonomy. First, robots will handle narrow subtasks like camera movement, tissue tracking, knot tying, or safe boundary enforcement. Then they will assist with sequencing, error detection, and recommending the next best move. Only after that will higher autonomy in selected procedures become realistic. The first human uses will likely be the most structured tasks in the most controlled settings with the most intensive supervision. In other words, autonomy will probably enter surgery the way aviation entered autopilot, slowly, narrowly, and only after terrifying amounts of testing. But once the threshold is crossed, medicine may never look the same again. Because this is not only a machine story, it is a story about whether expertise can be encoded, scaled, and redistributed without losing the judgment that makes medicine human. If autonomous surgery works, it could make precision less dependent on geography, fatigue, and individual talent. If it fails, it could expose the brutal truth that some parts of healing cannot be reduced to code. And that is why the most important cut these robots will ever make may not be in flesh, but in the boundary between assistance and authority. Because the moment a surgeon lets go, the future of medicine will finally reveal whether the machine beneath the operating lights is just a tool, or something much closer to a partner